Welcome students. We'll start with the topic similarity. In similarity, in similarity, we are first going to learn a ratio of area of two triangles. There are three important words. First is ratio. That means we are going to compare. For comparison, what we need? Two triangles. And what we are going to exactly compare? We are going to compare areas of two triangles. So shall we begin? On your screen, two triangles, triangle A, B, C and triangle P, Q, R. In triangle ABC, in triangle ABC, AD is the height of the triangle and BC is the base of the triangle. Please note AD is perpendicular to BC, that's why it is height of the triangle. Similarly, in triangle PQR, PS is the height and QR is the base. You have already learned previously, if we were to calculate area of the triangle ABC, the formula would be 1 half base into height. Same is applicable for triangle PQR, 1 half base into height. We know base, we know height for both the triangles. So area of triangle ABC is 1 half BC, that is base, into height AD, 1 half BC into AD. Similarly, area of triangle PQR is equal to 1 half PS, which is height, into QR, which is base, 1 half PS into QR. Now I mentioned at the beginning, focus on word ratio. Ratio is nothing but comparison. We have areas of two triangle. Let's now compare them. So for comparison, we divide one area of triangle by another. So that's why area of triangle ABC divided by area of triangle PQR. What we get? We already know area of triangle ABC, 1 half BC into AD. So we get 1 half BC into AD divided by 1 half PS into QR, which is nothing but area of triangle PQR. 1 half upon 1 half gets cancelled out. We get BC into AD divided by PS into QR. Now pay focus here. Let's call AD as height 1, that means H1. So for triangle 1, we call it height 1, H1. And PS, height of second triangle, let's call H2. Similarly, let's call BC, base of triangle 1, B1. And QR, base of triangle 2, B2. So we have now H1, H2, B1, B2. Using these names, what we get? BC into AD, nothing but B1 into H1 divided by B2 into H2. So, ratios of areas of two triangles are dependent on their base and their height. Let us further look into the concept of ratio of area of two triangles. We have condition 1, if the height of both triangles is equal. So on your screen there are two triangles, triangle ABC and triangle PQR. From its size you can recognize that both the areas would be different. But if you look carefully, the height of the triangle ABC and PQR are equal. We have just seen previously area of triangle ABC divided by area of triangle PQR is nothing but base 1 into H1, means base of that triangle into height of that triangle divided by base and height of another triangle. In this case, divided by B2 into H2. B1 into H1 divided by B2 into H2. But H1 is equal to H2. That means the height of the triangle is same. As the values of height of the triangle is similar, it can get cancelled out. What we get? Area of triangle ABC upon area of triangle PQR is nothing but B1 upon B2. If height of both the triangles are equal, then ratio of areas of those triangles depends directly on their base or base length. Now let's look at the condition number 2. If bases of both the triangles are equal, Here on your screen you see again triangle ABC, triangle PQR. Now here the height of the triangles are different, but base length BC is equal to QR. So base of both the triangles are equal. Again we say H1 for triangle 1 height, H2 for triangle 2 height, B1 for triangle 1 base, B2 for triangle 2 base. If we take the ratios of these two triangles, area of triangle ABC upon area of triangle PQR is equal to B1 into H1 upon B2 into H2. That means base 1 into height 1 for the first triangle divided by base 2 into height 2 for the second triangle. But here base 1 length is equal to base 2 length. So what happens to B1 upon B2? As they are similar values, we can cancel them out. Then area of triangle ABC upon area of triangle PQR is equal to H1 upon H2. So what we conclude from this? For the ratios of areas of two triangle, if height of both triangles are equal, then the ratios of those two triangles depend on their base. That means B1 upon B2. And if bases of both the triangles are equal, then ratio of area for both the triangle depend directly upon their height. That means H1 upon H2. Let us solve some easy problems so that you get a good hold of concept of similarity. The first one is the base of triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Then find the ratio of areas of two triangles. On your screen, you see two triangles, one ABC, another triangle is PQR. Triangle 1 base is 9 and height is 5, which is already given in this problem. Base is 9, height is 5. Similarly, for triangle 2, base is 10, height is 6. Base is 10, height is 6. So let's call triangle ABC triangle 1 and triangle PQR as triangle 2. Base 1, that means B1 is 9. Height 1, that means H1 is 5. 9, 5. Base 2, B2 is 10. Height 2, H2 is 6. 10, 6. We have already learned area of triangle ABC upon area of triangle PQR would be base 1 into height 1 divided by base 2 into height 2. Putting the values, we get 9 into 5, base 1 9, height 1 5. We replaced it here, divided by B2 and H2 already given here 10 and 6. 10 multiplied by 6. Simplifying it, 3 2s are 6, 3 3s are 9. So remaining is 3 and 2 here. 5 1s are 5, 5 2s are 10. So what we get is 3 into 1 divided by 2 into 2, which is nothing but 3 divided by 4. Hence, area of triangle ABC upon area of triangle PQR is equal to 3 upon 4. So this is the ratio for two triangles, 3:4. Let us solve one more problem. In given figure below, BC is perpendicular to AB. So BC or CB is perpendicular to AB. AD is perpendicular to AB. AD is again perpendicular to AB. BC or CB length is given as 4. AD or DA length is given as 8. And they have asked us to find area of triangle ABC upon area of triangle ADB. The given data, BC or CB length as 4, AD or DA length as 8. Hence, in triangle ABC, that means this triangle ABC, this upper triangle, B1, let's call B1, that means base 1, AB is the base. Since this is the first triangle, let's call it as a B1, AB, B1. CB length, this is height, let's call it H1. Similarly, in triangle ADB, that means the bottom triangle, let's call it triangle 2. Hence, AB again is the base, let's call it base 2, B2. AD is the height. So let's call it H2 AD. We have already learned area of triangle ABC upon area of triangle ADB is relationship between base into height for both the triangles. So B1 into H1 divided by B2 into H2. But we already know B1 and B2 are same. That means both triangle base is same. AB is that base. So we get AB into CB upon AB into AD. What is left is CB upon AD. So area of triangle ABC upon area of triangle ADB is equal to CB upon AD. That means it is totally dependent on the ratio of heights of the triangles. And we know the heights BC or CB length is 4, AD length is 8. So 4 upon 8. Replacing these values we get 4 upon 8. Simplifying it 1 upon 2. Hence area of triangle ABC upon area of triangle ADB is 1 upon 2. Let's solve the next problem. The first question we need to ask is what is the given data? The first given data is PS is perpendicular to RQ. Let's find where is PS. Here is the PS. Now PS is perpendicular to RQ, but RQ is up to this length. That's correct. But RQ is extended as RS, and then PS is perpendicular to RS. Hence PS is perpendicular to RQ. This is given. Next one is QT. Let's find where is the QT. QT, here it is. It is perpendicular to PR. It is quite easy to understand, right? Moving on to the next given data. The next given data is RQ length, which is given as 6. I have highlighted the RQ length in purple color. The next value given is PS. This is vertical. PS given as 6. Next we have PR or RP as 12, highlighted in green. And we have been asked to find out length QT, which is highlighted in red. I'm just summarizing. RQ 6, PS 6, PR 12 and QT we have been asked to find out. Now pay attention to the area which is highlighted in yellow. Do you see our triangle? Triangle RQP, or we can call it as a triangle PRQ. Both are the same triangle, but the way we name it, there's a difference in the calculation of area of the triangle. Let me explain that concept because problem would be solved easily when you understand that concept. So in triangle RQP, what is base? Base RQ. But what is height? Height would be PS because height is the perpendicular to the base. Right? So that's why when we say triangle RQP, the base becomes RQ, height becomes PS. But for the same triangle, if we say triangle PRQ, in this case, the base is PR and height becomes QT. Are you getting this? If we call it as triangle RQP, RQP, RQ becomes base, PS become height. If we call triangle PRQ, PR becomes base, QT becomes height. Whatever name we call it, we know that triangle RQP is nothing but triangle PRQ. They are actually same triangle. If they are same, then their areas are also same. So area of triangle RQP is equal to area of triangle PRQ. How we calculate area of triangle? 1/2 into base into height. So what is the base for triangle RQP? Given here. RQ is the base. What is the height? PS given here. So substituting we get 1/2 RQ into PS. Similarly, area of triangle PRQ. What is the base? PR. What is the height? QT. So 1/2 PR into QT. Solving the equation, 1/2 on LHS and RHS gets cancelled out. What remains is RQ into PS is equal to PR into QT. We know values of three sides. We know value of RQ, which is 6, already given here. We know value of PS, again 6, given here. We know value of PR, 12, given here. And we need to find out QT. That's why 6 into 6 is equal to 12 into QT. Now problems become easy to solve. Sending 12 to LHS, we get 6 into 6 divided by 12. 12 goes into denominator, is equal to QT. 6 into 6 is 36. So we get 36 upon 12 is equal to QT. 12 ones are 12, 12 threes are 36. Hence, QT is equal to 3. Wasn't it easy? Let's look at the next problem. In the figure given below, AP is perpendicular to BC. Let's find out where is AP. AP is here. AP is perpendicular to BC. And AD is parallel to BC. Here is AD, which is parallel to BC. And we have been asked find area of triangle ABC as to area of triangle BCD. Nothing but we have been asked to find the ratio. Let's look at the given data again. Given data is very simple. AP perpendicular to BC, AD parallel to BC. We don't have any value, but still we can find out the ratios of these two triangles. Let's see how. I have highlighted triangle ABC in blue color. So can you now visualize triangle ABC? Good. Now I have highlighted triangle BCD in red color. Can you see it? What is the first thing you notice? That's correct. Base of both the triangles is common. We are going to use the same to solve this problem. Let's just first find out area of triangle ABC. That means blue color. This triangle ABC area would be 1 half. The base of the triangle is BC, hence 1 half into BC. Height of this triangle is AP, hence AP, 1 half BC into AP. Quite simple. Now focus on triangle BCD, which is highlighted in red color. Area of triangle BCD is 1 half. Base we know, BC. How to find out height? That's where we use given data. We know AD is parallel to BC. So if we draw a perpendicular from point D on BC, that would be the height of this triangle BCD. Even though it is outside the triangle, but that would be the height of the triangle. So we have drawn a perpendicular from point D to point E. Now this has become height of triangle BCD. So area of triangle BCD is 1 half into BC into DE. Let's take the ratio of both this triangle. Area of triangle ABC upon area of triangle BCD is equal to 1 half into BC into AP upon 1 half into BC upon DE. What do you see? Yes, 1 half and 1 half are common on numerator as well as denominator. Same goes with BC. BC, that means base of both the triangles, are again common. So it gets cancelled out. What is remaining is AP upon DE. That's what we have learned. When the base is common, the ratios of triangles are dependent on their heights. Height of triangle ABC is AP, height of triangle BCD is DE. But wait, if you look carefully, length AP is equal to length D. Why? Because AD and BC are parallel lines to each other. So whatever number of lines we draw perpendicular between these two, the length of all those lines would be similar. Hence AP is equal to DE. Hence area of triangle ABC upon area of triangle BCD is equal to AP upon AP. We can call DE is equal to AP. Hence AP upon AP, or DE upon DE. We can call AP as DE, which is anyway going to get cancelled out. Hence, area of triangle ABC upon area of triangle BCD is equal to 1. Let's look at the next problem. In the figure given below, PQ is perpendicular to BC. here is PQ perpendicular to BC, and AD, here is AD perpendicular to BC. And we have been asked to find out area of triangle PQB upon area of triangle PBC. Next, we have been asked to find out ratio of area of triangle PBC to area of triangle ABC. Next, area of triangle ABC to area of triangle ADC. And last, area of triangle ADC to area of triangle PQC. Let's see how we can do it. Given data, PQ perpendicular to BC, AD perpendicular to BC. We have already learned ratios of areas of triangle are product of their base and height. That means base 1 into height 1 for triangle 1 divided by base 2 into height 2 for triangle 2. Let's see the first ratio of area of triangle PQB upon area of triangle PBC. Triangle PQB is highlighted in blue and triangle PBC is highlighted in green. These two green lines are just for the purpose of highlighting. This is the entire PBC triangle. So ratio of these two triangles is product of their base into height, hence B1 into H1 upon B2 into H2. If you look closely, height of both the triangles is equal, which is PQ. That means H1 is equal to H2, which is nothing but PQ. So H1 and H2 gets cancelled out. What remains is base QB upon BC. QB upon BC. Hence, area of triangle PQB upon area of triangle PBC is equal to QB upon BC. Let's now find out second ratio. Area of triangle PBC upon area of triangle ABC. Again, triangles are highlighted in two colors. PBC is highlighted in blue. ABC is highlighted in green. Again, we will get the ratios by B1 into H1 upon B2 into H2. But if you look closely, both the triangles have common base, which is BC. Hence, B1 is equal to B2, which is nothing but BC. Hence, B1, B2 gets cancelled out, and the ratio of these two triangles will be dependent on its height. What is the height of these two triangles? H1 is PQ and H2 is AD. Hence, area of triangle PBC upon area of triangle ABC is equal to PQ upon AD. Let's find out the third ratio. Area of triangle ABC upon area of triangle ADC. ABC is highlighted in blue. ADC is highlighted in green. I'm sure you must have noticed both the triangles have common height AD. So B1 H1 upon B2 H2, what is going to happen is H1 and H2 are same. Hence, area of triangle ABC upon area of triangle ADC is directly dependent on their bases. What is the base? ABC base is BC, ADC base is DC. Hence, BC upon DC. Let's look at the last ratio. Area of triangle ADC upon area of triangle PQC. ADC is highlighted in blue, PQC is highlighted in green. Again, B1 into H1 upon B2 into H2. But in this case, neither height nor base is common. We have to directly take the B1 H1 and B2 H2 as it is. What is B1? Base 1 for ADC. ADC is DC is the base, AD is the height. And for triangle PQC, QC is the base, PQ is the height. Hence, triangle ADC upon triangle PQC is nothing but DC into AD upon QC into PQ.